Hello, everyone. I'm Irene Zen, Director of Product Marketing, focused on service provider security. This session, we'll talk about how organizations can do DDoS protection and command and control protection with MX Security. And we're going to demo specifically the two offerings and capabilities that with SecIntel and Corero TDD. So here, I wanted to circle back to what Kate said about Juniper Connected Security as our vision and strategy. The idea of extending security to all points of connection across the network to safeguard users, application, and infrastructure. Now, with this idea, realistically, it's unrealistic to anticipate having security appliance to every point of connection with those dedicated appliance. And because at least economically, that would be not feasible. So a better approach would be, why not deliver the protection through the convergence of security with network infrastructure. And Juniper, we as a networking and security company, we feel that we are very much uniquely positioned to be able to do that. For those that may not familiar with our MX, which is our MX series routers, probably the most well-known product from Juniper that has over 20 years of history, one of the most powerful routers. And we can say that even the internet, a large portion of internet is powered by the MX. And if you look at all the major service providers, content providers, and even large enterprises, they will have Juniper MX in their network. Then as we think about strategy, how do we really support them in transforming their network with our Juniper Connected Security strategy and transform those networks into a threat-aware network? Wouldn't it be great if we can help them leverage the MX routing platform that they already have, but simply by adding whether it's services card or turn on software that allow them to have both the routing and security. So that is the whole idea. So you see on the left, there's like three offerings that we have. There's the services card, where for those MX as a chassis that you can plug in the services card to have CGNet capability, stateful firewall, IPsec, URL filtering, IDS, etc. And then with SecIntel, that is a subscription service where you can subscribe and able to have real-time threat intelligence that allows you to have line rate detection, blocking those malicious IPs, command and control hosts, and malicious DNS requests, which we're going to demo shortly after. And then last but not least is we have a joint solution with Corero and for the DDoS. And the powerful thing that very unique is that they bring in the software detection engine. And because our MX platform have the Trio chipset, which is very programmable, and that allows it to interface very elegantly to be able to do automated detection and mitigation of the volumetric DDoS attacks. Another thing to emphasize with the SecIntel and the DDoS is these are done at the router level that is line rate performance. A typical concern for service providers is that worry about the balance or trade-off between security efficacy and the performance, and specifically the network performance, the throughput performance of their network. And with this approach that we have, it doesn't have to be a trade-off because it's line rate. So first, the SecIntel on MX, how it works. These are the MX models that currently support with the SecIntel service, the MX 240, 480, 960, 204, and 10K3. The Junos version needs to be 21.3 or later. And how it works is that the policy enforcer enrolls into SecIntel, which is a service within the Juniper ATP cloud, and then regularly fetch or download the global command and control feed, IP allowed and blacklist, or previously known as whitelist and blacklist, and then also the geo IP feed. Those feeds will deliver to the MX RE, the routing engine, and consumed by the PFE, the packet forwarding engine, and based on the threat level as well as the defined action.
So is this meant to be positioned at the service provider edge or in the service provider kind of core? Which was kind of the best positioning for this?
The best position would be wherever you have the MX routers, and it doesn't have to be service provider. It could be, we also see enterprise that deploy MX at their data center edge or the campus edge. So it's wherever that you feel you want to turn that on, that you already have the MX, you can do that. For the DDoS, we do see a lot of that turn on at the peering site. All right.
But it does make sense to have some services that can be using those services by the service provider.
And then this is the scenario one, where we demonstrate how the user try to access the known command and controlled IP address that is bad, and how you can see that the MX router able to detect and stop it.
So my question, is this just IPs, or is this IPs and URIs? What?
So for the capabilities, we do both the IPs and DNS. For this demo specifically, we chose command and controlled IPs as a scenario. All right, so log into the MX platform and show config services security intelligence, where it demonstrates that yes, it's downloading the manifest of a command and control feed. And then when we show the update status, it's done a while ago. And show the filters, where we see that for the policy, we call P1, essentially the policy where for threat level that is 8, action is drop, log, and sample. Similarly for threat level 9 and 10. And then for the filter template, we call it template 1. And now let's start with the shell, drop it into the PFE level. And in this case, that is the FPC2. This is the filter index. And now let's pick an IP address that is known as bad and try to connect it. And to do that, we open the Ubuntu and the make terminal, IP route show. The default is the source address here we show, and ping. First, try to make sure that we have the internet connectivity, and it shows that we do. And then now we ping the address that we show. And now as we try to connect that and going to the secure analytics to the logging and see whether any log that has been taken and any actions. And there you go, we do. There's FPC2 at the PFE level that try to connect, and that is the interface. And then this is the source address, source IP, and the destination IP. The threat level is 8, and the action is job. So that is how we show that it works. And then another scenario where I want to show is the scenario 2, where that is very relevant for service providers, as well as even large IT teams where they manage the global organizations where you want to have that multi-tenant ability. So with the MX platform, you can use the VRF, virtual router functions, to be able to do that. Similar how it works that we already show. And for the demo, very quickly. All right, so we log into the security director interface, which you already saw earlier in this session. And then we go to the policy enforcers, which show that it is connected to the Juniper ATP cloud already. And then next, going to the device and the tenants, where we, in this scenario, we set up 3 customers, and each one tagged with specific VRF. And then when you go to the site, because they are treated as 3 independent customers, so we need to set up 3 independent sites, and the name needs to be the same as the VRF naming that we all have. And then for the status, it's all success, meaning that we already downloaded the threat feed. For the feed sources, here you can see there's a couple of different threat feed that you can download. It doesn't have to have all the feeds download, you can pick and choose and also create your own custom thread feed. So what we're trying to do, running some command, is simply to validate that those thread feeds have been downloaded, and also those via each customers or subscribers or organization, depending on how you want to use the multi-tenant, are really having each category. So we show that for the thread feeds, for blacklist, command and control, and whitelist, each one you can see that it is tagged and belong to each VRF. So that is how we support multi-tenancy with the MX security with the SecIntel.
So how is it doing the query? Is it doing a DNS query to a blacklist and saying, hey, you're not allowed? Or is it going to a whitelist and saying, you are allowed? Everything else is denied. Is it more DNS or is it something else?
The list that was shown on the demo was a updated list every time there is an update directly to the router. So it's not doing any DNS lookup here. But there is a DNS sync all feature where you can also look at for DNS requests. But it's a different feature that is part of the SecIntel feature also.
Right,
it's a different approach in that case.
And can it do a whitelist instead of a blacklist? Can it just say all these things are allowed and everything else is denied?
Yeah, whitelist and blacklist per customer, per tenant, depending on what you want. So URL filtering, CNC feeds, blacklist, whitelist, or block list and allow list.
Blacklist.
Yeah,
thank you.
Yeah, you have the option of blacklist and kind of allow list and block list, and then also all of the kind of feeds that we're providing are kind of global feeds that we provide to all customers that are generated by our threat intelligence and Juniper Threat Labs team.
Okay.
All right, now let me turn it over to Laurent to talk about our joint DDoS solution with Corero.
So let's go back to this small animation. So it shows how the joint solution works for what we call TDD, Threat Defense Director. So it's mirroring traffic out of the inbound link or links. So it's mirroring by default 1,000. So if you have 1 terabyte, it's just mirroring 1 gigabyte to analyze. Then it sends also telemetry at the same time, and that will be very useful when we got the DDoS coming in. At some point, when some hackers come in and send some attack, it will also continue streaming those, and it will get some of the attacks coming in, analyzed, and then it will be able to directly generate a filter. It just takes a few seconds with a dynamic payload. That's very interesting because you have the usual source, destination, ports, and so on, but you have also possibilities to have a payload on this one. And then it's still continue feeding with telemetry and with some sample of the attacks that is blocked now. And then we know exactly when it started, when the attack ends, and then when it's done, it's able to remove the filter. So the idea is to be able to do that live for many customers, for one or many customers, and to share this platform that can be shared with multi-tenancy also. So an SP could sell it for some customers, but not all, or with some various settings for each of its customers. Like one will be monitored only, another one will be in protection mode, basically. That's multiple possibilities. It's also supporting BGP flow spec action. So if you have a non-MX router, because the MX has much more capabilities with the trio chipset, with the firewall filters and including payloads, but it's able also to use BGP flow spec with other platforms. And the idea also is to use them with various actions, and I can show that in the demo. IP intelligence plugin was added also to give more visibility. We have also possibilities to see per country attacks and per ASN numbers. So AS number is the BGP number for the autonomous systems. I will go quite quick now. And then we have added in this release also GTP inspection. This is clearly for mobile traffics because we can see attacks coming inside this GTP tunnel used on the mobile side of the traffic of the network. So let's go into the setup. It's very simple with multiple routers. I will not go into details. I will just show you this live. on this demo. So this is the UI for TDD. Here I've got an Ixia traffic generator, and I've got it's a VMX running behind. And then I will show you the traffic. So we have a steady traffic of very small amount of traffic on packets. Let's imagine in a real network you have some more zeros here, but that's just enough to show the thing. You have 10K PPS in and out of each of the two VMX. And when we launch the attack, so we just launched this DNS reflection attack, that was added to the Ixia system. We just double the amount of packets and traffics, and it will just take a few seconds before you see here the output going down back to where it was. So here is down. So that was the time of detection between the time it was clicked here and then the time the reaction is done on the distributed routers. So we have also a Slack output here if you want to get that, to get some more visibility on some other platforms. And then when we refresh, sometimes we just have a small delay on the web interface to show that, but because it was at 30-second delay, so we just change it and refresh it. I will just quickly go here, and then you got that filter that was dynamically created. So here you see we have that's a policy number detecting these attacks. It's a UDP 53, source IP 53. So we have the same here. And let's go back here. And you will see soon some telemetry coming in. Telemetry is a small delay. But you can see the 10K PPS out. And then if we go here, we go a bit quicker just to get some time. We have the telemetry showing how much this filter matches, how much is blocking actually. So we have 45 megs out worth of attacks, almost 12K packet per second of the attack, and that's live. When the attack is done, some minutes later, it will automatically remove that filter from the MX. But let's look at what was done also with some more details. On the last 24 hours, we can see for that tenant how much attack. So we have 1 ongoing attacks, 1 is under attack. We have 4 mitigated attacks. So we are all the past of what happened to this tenant. If we filter per tenant or per customer or per attack, we can filter that in many ways. But that we can get more details on each of them when needed. If we go to the tenant per customer portal, the service portal for the customer itself. So you can see the history behind on this last 24 hours. You can see a very long attack that has a very long duration here. And we're just refreshing to get the updated attack, and we can see the ongoing attack coming in on that resource. And then we have also some details on this is a DNS response reflection attack. We add some other attack like a SYN hack reflection also. And then we have this very long attack, which is just at the top. If we just click on this attack, we get directly to that also. We have a second attack behind it just to show the same. I will just accelerate. And it will show basically the same thing, but this is an NTP monolith attack in this case. And in this part of the demo, what I wanted to show you is the content of the firewall filter that was created for that attack totally dynamically. So it's a destination-based filter based on some other criteria. So we have the usual 5 tuple here, and we have the payload, which is very interesting. I think past the content of the previous attack, but you've got some other contents in the previous attacks. And here on the right router, we just change the config of this one, not to get that dynamic firewall filter, but to do BGP flow spec instead, just to show you how different it is and how interesting is this kind of firewall filters with this payload, because that's the content of BGP flow spec filter, which is much less granular than a firewall filter done at the ASIC level by the Trio chipset. So we have got basically the same header on the 5 tuple, but not the rest. We have some lengths here that were not set on this filter, but sometimes the filter is set with some other parameters here. Source country visibility is shown you here. So you can filter by timing, by countries, by various ways, of course. Of course, you have some country not available when we are using all private IPs, but you have got a lot of other countries. And if you filter by countries, you can all the attacks coming from a specific country. I will just accelerate here. And then you have got this one matching. We have this very long history that matches a very long attack during the night that was shown, and then all the various IPs. So it's DIPs, destination IP, and source IP that were shown here in this attack, on this very long attack, on the filters that were triggering on TDD. So that's the internal name for matching those specific attacks. So one of them is DNS reflection, the other is NDP mon list, but here we don't need to know the details. And we have this ASN view. So it's similar to country, but for the autonomous system where this traffic were coming from. And next, I will show you. So we have basically same kind of information. Yeah.
You mentioned private addresses and that one, yep, right there. There's not available. So do you have the ability to correlate with what should be some form of a trusted entity? Or, I mean, that's 80% of your traffic right there. So how do you correlate that large chunk of private IPs?
It's totally private IPs, like in the range of RFC 1980. So you cannot really correlate with external information here. That's correlation with external sources. So when you get an IP like 1.1.1.1, it's coming from from external IP. So it has a matching with a public ASN number.
So you
that's where that's what it shows.
Resources?
I didn't see a way to add my own internal BGP number if it's what you are asking for. But probably we can ask for that to Corero. Yet I didn't see that. On the latest part of the demo, it's just to show you that we can also inspect GTPU, so which is a tunneling part of the traffic for mobile user, like on your handset or anybody connecting on 5G. And then there is a small traffic generator here with a few attacks on where we are able to extract information for that user. And we have got a GTPU decapsulation, that's the source and destination of the tunneling itself. And then we have got the internal IPs assigned to the handset.